Hello. So I've opened up the first script that we'll have a look at. But before we get to the actual CG reconstruction, I have to spend a couple of minutes on these backdrops at the top. So these things here. And I'm doing that just to avoid any confusion. So basically ignore this setup at the bottom here, or the the part at the bottom. Just ignore that for now, and let's just have a quick look at the top. The very top backdrop should be self-explanatory. As you can see, this is essentially where my data is coming in. So this is basically where I pull in my renders. And as you know, in this case, I just have a one frame of a multi-channel EXR. And, just to reiterate, we have the regular render here with a backdrop. We have the same render but without a backdrop, and therefore, an alpha where we can see some edges. So over here, it's just white. And then over here, I got my utilities. So that should be pretty self-explanatory. Then right beneath that, I have these things here. And in case you don't know this already, these are called stamps. And they are essentially like no-op nodes with hidden inputs, but on steroids, kind of. And they've been created by a guy called Adrian Puello. And hopefully I'm not butchering his name too badly, but if so, then I'm sorry, Adrian. Stamps are simply very, very useful to have. So I'll put a link in the description to where you can download what you need if you want to get them, and where you can find tutorials, etc. So anyways, why hidden inputs? Well, hidden inputs, and particularly stamps, I think, are very, very good for organizing your scripts. Where you can basically avoid having comp scripts that's got lots and lots and lots of pipes going everywhere in any direction, and you have a better chance of keeping things clean and nice. Now, there are a couple of things to bear in mind when using stamps, but this is, of course, not a course about these kinds of topics, so just bear in mind that I use them in pretty much every comp that I do nowadays, including here. Okay, enough about stamps. The next section down, here, is really just a section where I organize my data, or my data streams, before I pipe data out into CG setups, like here, and, similar things. So what you'll see here is essentially how I do this whenever I work in a place that does not have a set way of organizing it for you, as in when it's not in their pipeline, for example. So yeah, again, this is my way, and other people will have other ways of organizing their data, but there's really no magic to it. I just section things out into data streams for things like my beauty, which is going to be an RGBA, the additive passes, so meaning the passes that I'm going to use for the beauty reconstruction, utility, I have a utility section over here, and then cryptomats over here. And all the remove nodes that you see, so that will be things like here, remove nodes are going to, if we look at it like this, are going to be there just in order to remove stuff I don't need in that particular stream, or alternatively, to keep things that I want in the stream. And then all I do is, I label things properly, and I put in stamps at the bottom so that I can basically just press F8, for example. Here I get myself a stamp. I mean, these are called anchors, and here's the real the stamp. And then I can take this data wherever I want in my comp. So basically like here, for example. So you'll see these two sections here in all the scripts that I will open up for this tutorial. And that's pretty much it, which means that now I think we can finally get on with analyzing the first setup type, the simple additive setup. Now let's look at the setup itself, and let us find out what's good about it and what might be not quite so good about it, because of course I've labeled it as a flawed setup. The first thing to think about is the obvious thing. Simple additive setup implies two things, of course. One, that it is additive, and the other one is that it is simple. And it is, in fact, the simplest way to reconstruct your beauty, at least the simplest way I can think of. Because the only thing that we really need to do is to add all the AOB passes of a given AOB set. Remember, we talked about sets. To add all of those together to retain then the exact equivalent of the RGB beauty. And then we should be able to grade each pass individually just as we please. So that's good. But is it the case here in this setup? Let's have a look, and let us zoom in then and do things from top to bottom. Let's just do a walkthrough. At the top, we have our additive passes coming in, as we can see. I don't know, we got spotlights and we've got reflections. All these things are coming in here. Then the next step is we're using a shuffle node to shuffle in the RGB A. An important bit is we now have an alpha. And then we have this, it says CG in. Well, that's great. That's basically the starting point then. After that, we have a pipe going down and a pipe going over like this. And then we have some shuffle nodes over here. And in those, we are shuffling out some passes. It says SR, that means screen right, spots. We got the fill. So this basically is a light group pass. And that means we need to check if they all belong to the same AOV set, as I call them. Fill light, high key light, and environment. I happen to know that we actually have 6 lights in our scene. We've got 6 shuffle nodes, and we can see they are actually, or they're not the same, but they all belong to the same AOV set. So that's correct. That's good. If we look at the merge nodes then, we're going from here, and then we're daisy chaining the merge nodes together, all with a plus operation, which means that when we get to the end over here, so not here, but here, we should basically have the same thing as our beauty. So if I've now put my viewer on 1 on this spot, and then I'm going to put my viewer on 2 on my beauty. And that means I can now go up here and I can flip back and forth. And we see we have pretty much the same as our beauty. So that's pretty good. Okay, let's walk further then. Then we walk to the right here, and we find that we've got a copy node. This copy node copies in an alpha. So that means at this point, we are definitely certain that we have the alpha in our scene. And in this case, right now, we just have a white alpha. So that's pretty good. And then down here, we have an overall grading section before we go to the CG out. So the overall grading section, that's pretty good as well, because this is where you're going to do, as it implies, an overall grade. And things like adjusting your black levels and stuff like that. So that's a pretty good thing to have. So that means we've gone through this, and then we can basically say that the good parts of the setup is that we are shuffling out. In this case, it's the light groups that we're shuffling out, and we're not mixing, because in the additive setups, you can't mix between different types of AOVs or different sets of AOVs, and we're not doing that. So that is correct. We are just simply adding them together. That's also correct. But there are some flaws, of course. The first thing you might have noticed already, if we're looking at it like this, you can see that in the overall grade, we have an unpremult node here. So basically, we are unpremulting the result of what's happening up here with our alpha, doing our grade, and then we're pre-multiplying down here. That's correct. Except, of course, if you look here, there's no unpremult here, and there's no unpremult here, which means that all of these passes, they have not been unpremultiplied, and they should be. So effectively, actually, let's go up here, and let's switch this to the alpha that actually, where we can actually see the edges and stuff. Essentially, if we're zooming in, let's just see here, and we look at this here, you can see that we have we're in a pre-multiplied state, because when we're unpremulting now, this happens. You can see here, hopefully you can see that in the video, the difference between here and here. So now we have unpremultiplied our image with the alpha, and that is exactly the state that we need to be in when we're grading. But we're not in that state on any of these passes, or rather when I look here, all of these things are pre-multiplied. So that's actually wrong. That means that this node, this unpremult node, needs to be up here for this setup to be correct. I would consider this here technically wrong. So that's the first flaw of the setup. Then the second thing is that we said that we're going to try and keep our data sparse. And if we look here, so the CG in and the CG out, let's just zoom out like that. Let's go back to the image that we like to look at. If we're looking at our CG in and our CG out, and we can flip back and forth between them. So here, up here, we have access to all the additive passes. Whoops, all the additive passes. And if we go down to the bottom, we still have access to all of them. We don't really need to. At this point, we've already done our grade, so we really only need our RGBA at the bottom here. So that means that we're not really getting rid of any information that we could get rid of. This is not a big fault. I can't say that it's technically wrong, but we did set up the rules in the beginning and promised to ourselves that we would try to basically delete information whenever we can, and we're not doing that. So I would consider that a flaw, although it's not technically wrong to do it this way. I think we can still improve on it. Then it's the third flaw. This is actually a very minor thing. Again, not technically wrong, but we said that we would try and stick to a top-down type of setup as much as possible, and that means that we should try and keep the main B pipe running down here, and it looks like it's doing that here, but actually it's not. Because as you can see here in the shuffle node, the B pipe is coming in from this side. So what the B pipe is doing is going around like this in a loop, and then we have the B pipe going through all of these merge nodes before it's coming in here, and from the top we're actually getting the A pipe going in with our alpha. Again, this is not wrong. You could choose to set it up this way, but I would like to set it up slightly differently so that it's even more clear that the data is flowing from the top and down. That's the third thing. Now there's a fourth thing as well. If I'm looking at here, this is my reconstructed beauty with all the passes, and here we can flip between them again, and basically we see that we have our beauty reconstructed. Or do we? If I actually zoom in here, you can see, hopefully again, I don't know what the video will show in terms of how it's been, you know, what the quality of the video online will be, because of course it may have some compression done to it, so it might be a bit difficult to see. But at least if I zoom in like this, in this area, you can see that this is my reconstructed beauty. This is the actual beauty. And you can see there are minor differences, meaning we are not identical. Now, why might that be? What is causing that? I think that the answer to that I will show you in a second when I pull in or open up the script that actually has the fixed setup, the fixed simple additive setup, and then we can compare the two, find out where you know, the things that we have fixed and how we fixed it. And after that, I guess we can move on to the next setup. But first, let's have a look at the improved setup. And here we have the fixed simple additive setup, as you can see, side by side with the setup that we already looked at. And as you can see, overall, it looks really, really similar, but not exactly the same. What I like about the previous setup, if we zoom in a little bit, like here, is the overall structure of the setup. It's very simple, very easy to read, and so I've kept the overall structure over here in the new setup, but obviously with the needed changes. So let's jump in and have a look at the fixes and improvements that we've made first. Let's do that first. So first of all, you can see, if we keep these a little bit zoomed in, yeah, something like that. Remember, there's an unpremult down here that was in the wrong place. That's the first thing that we've moved this up here. So now the unpremult is in the right place where it unpremults everything that's coming into the stream. So if we demonstrate that, it's going to look like this. And for this, I want to have a quick look at the one with this type of alpha. And let's look here. Yeah, actually, here we'll go to the unpremult. And let's just do it this way. You can see it's getting unpremultiplied. Hopefully you can see this in the video. It's pretty easy to see here. This is basically how it comes in pre-multiplied. Now it's unpremultiplied. And that means one thing that is crucial to note is that if we put down an unpremult node here, normally it's set to divide by RGB or divide alpha by RGB. So dividing anything by an alpha is the same as unpremultiplying it, but just doing it for the RGB is not good enough for us. We are going to need to set it to all, which this one is, in order to ensure that when, let's just say we look at the high key maybe, yeah. So that when we're looking at actually one of these passes, here's an environment, here's the key light, here's a fill light, top fill light, but I guess it's better to see in this one. you can see that if I switch this on, off, and on again, you can see here that all the individual passes also get unpremultiplied. So that's the first thing. Then we have the issue, or the minor issue, with the fact that we have access to all of these channels throughout the previous setup. Here we're simply removing them so that from this point I just have RGB, no alpha, because my remove node is set to keep and keep RGB only. So that means that now in every single data stream, every single AOV shuffle, here we are keeping only the RGB information from this point on. Now the third improvement that I wanted to make was sort of a bit more of a cosmetic thing. Essentially, I would like to have, according to our requirements or the guidelines that we made for ourselves, I would like to have the main B pipe flow from top to bottom like this. And in this setup, of course, it flows around like this and goes in because the A pipe is coming in from the top. So in order to change that, what I did was I've got my CG coming in here. And then here I just remove everything. So now I just have a black frame with nothing in it, because this is removing all the channels. And then we've got our reconstruction taking place here. This is just getting, one pass after the other, getting added together, as it should be. And then we are able to simply plus the result of this onto our black frame. So there we have the B pipe coming from the top and the A pipe coming in like this. And that keeps the main data flow top down. Again, this is more of this is not this over here, I guess you can say, is not really technically wrong. So this is more of a cosmetic change, but that's basically how I would like to have it. And after that, really, there's not that much left. There is, over here, we still had this issue with the unpremult, and we injected the alpha up here. Well, now, taking care, as I said, about the unpremult, it's up there. And now I'm injecting the alpha, which I'm taking from my beauty. I'm injecting it after this overall grading section. And then we go to premult. So if we go before, have a look at before and after, everything should be fine. Taking the beauty in here and injecting it right before the premult is a good way of ensuring you have you actually have the exactly right alpha for you. So you don't, by some mistake in your grades, do a grade on an alpha that you have somewhere, being piped through. Doing it this way makes sure that you absolutely do have the right alpha. Now, there's one more final thing to fix in this setup. Remember that we didn't quite manage to get the reconstructed beauty to be exactly the same as our final beauty by just adding the passes together. There's still something missing. So let's first go back to the version here with the backdrop. Let's go out here and I'll demonstrate that again. This here, and I know there's a place here that's quite good to look at. Hopefully this is visible in the video with all the compression going on and stuff, but if I zoom in enough, you should be able to see it. This is our reconstructed beauty. Put my viewer on 1, and if I go here on the unpremulted state, this is my actual beauty, and you can see if I flip between the two of them, we now see that there is a difference. So what do we do about that? Oh, by the way, one thing I forgot to mention here is, of course, the reason why we're having this difference that we're seeing here. And that has to do with denoising, at least that's what I think. When I basically rendered this in Houdini, I had the option to use a denoiser, which I did, and I denoised both the beauty and all the additive passes separately. And so what you end up with is that there's going to be a slight difference between how the final beauty got denoised and how the individual passes got denoised. And so when you then combine these individual passes together, that's when you see, this minor difference. It's a sort of a pixel difference, really. So that's where that's coming from. And I've noticed that using a denoiser when rendering CG has become a lot more commonplace, at least in the jobs that I've had in the last few years, because of course it enables us to cut down on some of the render times while still getting a decent and clean looking result. So we should be vigilant and we should check for these minor differences that might be due to denoising or even slight differences in the noise patterns between the AOVs and the final beauty. So that's that. Well, then we're moving on to fixing it, and you might wonder if it's actually kind of tricky to do it. Actually, it's not really that hard to do. What we need to do then is we need to extract the difference and then simply plus it or add it back on top of this state here. The state where we have reconstructed our beauty as far as we can go using just our passes in this AOV set. And the way to do that is that we need to do kind of the same as we're doing down here, but we need to do it before the whole grading takes place. And that's what we're doing here. So this is one merge node, and this time I've just hooked it up to all our passes. I merge all of them together. So basically, if I now put this on 2 and this on 1, this is exactly the same, right? And then we have our beauty again, unpremulted, and then the remove node is just making sure we only keep the RGB because I don't really need the alpha anymore. So if we look here, alpha gone. And now we take this state and we subtract it from our beauty. So if I now, you can see here, then we are actually left with the difference between the two. If we now look at this image, hopefully now I'm taking the viewer and I'm gaining it up so you can see the difference. Basically what we've got here is, well, we've got the difference between the two inputs. And you can also see, which is kind of crucial, you can see that we have values in the positive. If we look at these numbers down here, we can see that we have values in the positive range and in the negative range. And that's actually quite important. I'll get to that in a second. Suffice to say that if we now take this, this difference here, let's put the image like that, let's put it back to normal, and we add that on top of the previous state that we have over here, we should now be exactly the same as our beauty. So again, if we go in here, let's do it this way. This is the reconstructed beauty with the passes on 1. This is my beauty. That's where we see the difference. And then on 3, I'm going to put our new merge node here. And now you can see that between 1 and 2, so between these places, we have a difference, but between the latest change and our beauty, we are now exactly the same. And that solves that problem. There's just one thing to mention here, and that is that when you are subtracting, when you're subtracting here, to get that difference, it's very important you use a subtraction operation. That would, in this case, in the merge nodes, that would either be a minus or a from. And they are the same, except in terms of which input gets subtracted from the other input. So we can go over here and we can hover over the operations, and you see the mathematical operations. And you can see the minus is A minus B, whereas the from is B minus A. There is an operation here called difference, and you might be tempted to use that in order to extract the difference. But if you look at the maths in this sort of yellow drop down here, you can see that it says abs and then A minus B. Abs stands for absolute. So what that operation actually does, it will take any value. If we find a value with negative values here, and it will take those values and remove the negative sign and make them positive. So it will basically only use absolute values. So I can demonstrate that by going up here and switch to difference. So you can see the numbers now, they're positive, and you can really easily now, because I put the gain up, you can really easily see what it's doing. So if I go back to my minus operation and switch to my difference again, you can see that all of these values have been made positive. And this is not correct. We need to have access to negative values as well, because when we're using an addition, or in this case, it's called a plus operation in Nuke, when we're plussing something with a negative value, what the result is going to be is, of course, that the pixel values that we have here, so let's take that down again, the pixel values that we have here, if we're adding a negative value, those pixels with the negative values are going to become darker. And the values that are positive are going to become brighter. So we have access to brightening pixels and darkening pixels if we've done this correctly. If we would have used the difference operation, all we could have achieved is to brighten pixel values, and that's basically not correct. So yeah, so we know that this is now exactly the same over here as our beauty, and we can go in and double check here. You can see here, we can get, so for example here, if we zoom in really far, we can see that this pixel here, for example, whoops, this pixel here is going to get slightly darker as we switch. Okay, and that means that this pixel here probably have a negative value in the difference that we created above, and other pixels are going to become, let's see if we can find one over here, are going to become let's see here, where do we have one? Yeah, so here, for example, this is the way it was before, and now it's brighter. So that had a positive value in the difference. So that's just one thing to note, and that's kind of a general thing as well. If you want to really capture the difference between two inputs in Nuke in general, you really should consider using a minus operation or a from operation instead of the difference operations if you need access to those negative values. But anyways, this is now correct. We're plussing that over black, as we said, and then we're doing our pre-multiplication down here, and that's kind of it. We have now, if I zoom out a little bit, we now here have a really nice, simple additive setup. You know, it's simple, easy to read, it's easy to use, and we've fixed all the issues that we had with the previous setup. There's just one little minor detail that I want to show you, which is I'll show you now a variant of the setup, which we have here. So if I do this setup and this setup is doing exactly the same thing. They have exactly the same fixes. There's no real difference between them except a kind of structural difference, which is that the lower one is stacking all these nodes on top of our black image from here, whereas up here we're daisy chaining our merge nodes in a horizontal way, and that's just kind of a stylistic difference. You will see when you see setups like this that some people prefer to stack their nodes, and I know, of course, that I said earlier that I would like to follow the design principle of Nuke, where the B inputs or the inputs are generally at the top of nodes and the outputs at the bottom. But actually, in this case, for this section of the setup, I prefer the horizontal daisy chaining. And the reason is quite simple, as you can kind of see, is that the real estate that we have available for our grade nodes is not the same for each of these, I don't know, for the lack of a better term, kind of like AOV data streams, grading streams. You can see that over here we have a lot less room for grade nodes than we have on the other side. Whereas if we do it this way, we have exactly the same amount of space for each grading stream. And so I just think that, first of all, this just looks nicer. It looks more clean to me, but it also has this advantage that we have the same amount of space for our grades. So that's basically it, I think. Although, of course, functionally, this setup here is the same as this. I prefer the setup here. Okay, I think that is it for the simple additive setup. And the next setup we'll be looking at will be a simple subtractive setup.